Fluid pressure is an important concept used in our day-to-day life. Design of water tanks. Dentist chairs. Suits for divers. Suits for spacemen. Petrol pumps and many other devices used in our day-to-day life are based on the concept of fluid pressure. Every substance, solid or fluid, exerts a force equal to its weight on any surface supporting it. This force per unit area is known as pressure intensity, or simply pressure. In case of fluids, the pressure is caused by weight of fluid pressing down on the surface. For instance, 10 kilograms weight of water in a straight-sided container with a bottom 10 centimeters square in area would exert a pressure of 9.8 newtons per centimeter square. In case of a rigid solid body at rest, the pressure due to self-weight acts vertically downwards on the surface at which it is placed. Behavior of fluid being somewhat different. Fluids at rest not only exert pressure due to self-weight on the base of the container, but also on its sides. This is because fluid pressure acts in all directions. This pressure is not only experienced on the sides of a fluid container, but also on any point within the fluid mass. At a given depth of immersion, the pressure force acts with equal intensity in all directions, but it varies with change in depth. To prove this, we have an experimental setup consisting of thistle funnel, having rubber diaphragm, tied securely at its mouth, connected to a manometer, tied at its other end. As the funnel is lowered in the tank, the liquid level in the manometer rises up. However, on moving the funnel in the same horizontal plane, the liquid level in the manometer remains constant. Thus we find that pressure at any point in the water tank is proportional to the water depth at that point and is exerted equally in all the directions in the same horizontal plane. Pressure exerted by fluid on sides of containing vessel is known as lateral pressure, and it depends on the depth of fluid above it. The magnitude of fluid pressure on any horizontal or vertical surface at a depth h below the free surface depends on the depth and the specific weight of fluid, W, and is given by pressure equals specific weight of fluid into depth of fluid column above the horizontal surface. In SI system, fluid pressure is measured in Newton per meter square. also called Pascal. In MKSA system, it is measured in kilograms force per meter square. The pressure at the bottom of a number of connected glass tubes of different diameters and shapes, each containing the same depth of water, will be the same. If there is a pressure P1 above the free surface of liquid, then the pressure at the bottom will be P equals WH plus P1. On increasing the pressure P1, the pressure at any depth must increase by exactly the same amount. Transmission of pressure equally in all directions was first established by Blaise Pascal and is known as Pascal's law. Pascal, a French scientist, was born in 1623. A precocious child, he received his early education from his father. After his mother's death, he was raised by his two sisters. Pascal devoted his earlier years for development of science and mathematics. His prominent mathematical contribution was his extension of previous studies on calculation by infinitesimal, which stimulated subsequent developments of calculus. He invented the principle of hydraulic press, which he called a machine for multiplying force. And finally, he succeeded in establishing the axioms of hydrostatics. In a fluid at rest, the pressure is transmitted equally in all directions. Known as Pascal's law, it was probably his greatest achievement, as it has worldwide application in day-to-day life. The principle of working of hydraulic gates, dumpers, compression machines, dentist chairs, etc., is based upon this law. Also, the working of hydraulic hoist is based upon Pascal's law. Air compressor increases the air pressure above the oil, which in turn is transmitted through the oil on the piston, lifting the car above the ground. This is done for necessary repairs and servicing of the vehicles. Like all other fluids, air also has weight. This can be demonstrated by weighing first an empty bladder and then weighing the same bladder filled with air. The difference in the two readings gives the weight of air in the bladder. Air also exerts pressure on the surface of the earth. This pressure is experienced by all objects, whether standing or moving on earth. In the air, water. The pressure exerted by an air column of unit cross-sectional area and having height equal to the height of atmosphere is known as atmospheric pressure. To experience atmospheric pressure, let us pour some water into a glass. Now, place a piece of glossy paper over the top of the glass and turn it upside down. We find that paper remains in position with water above it, even after the removal of the hand, apparently violating the law of gravity. In fact, both are supported by atmospheric pressure. Torricelli was first to measure atmospheric pressure in the year 1643 with the help of a barometer. In this method, a glass tube 1 meter long is filled with mercury right up to the brim. Closing the open end with a finger, the tube is turned upside down and is submerged in a cup of mercury. On removing the finger, part of the mercury in the tube falls. The mercury column left inside the tube is supported by the atmospheric pressure. Mercury level stands at a height of 76 centimeters at mean sea level. The atmospheric pressure varies with change in altitude. As the altitude increases, the pressure decreases. Basically, the atmospheric pressure at a place varies with change in temperature and density. That is why standard atmospheric pressure is defined as the pressure exerted by a column of mercury 76 centimeters in height at 0 degrees centigrade at mean sea level at a latitude of 45 degrees. The atmospheric pressure at a place is measured with the help of barometers, whereas pressure due to any fluid can be measured with the help of a manometer. To measure very high pressure, pressure gauges are used. Fluid pressure measured with the help of a pressure gauge or a manometer is called gauge pressure. The pressure less than the atmospheric pressure is known as suction pressure or vacuum pressure. The pressure measured above absolute zero or complete vacuum is called an absolute pressure. The gauge, atmospheric, and absolute pressures are related by the expression absolute pressure equals atmospheric pressure plus minus gauge pressure. As discussed earlier, the weight of water in the glass or weight of mercury in the glass tube is supported by the atmospheric pressure. The same principle of balancing is used to measure fluid pressure. The working of barometers, manometers, sphygmomanometers, and altimeters, etc., is based upon the principle of balancing the column of the fluid whose pressure is to be measured by the column of the same fluid or some other fluid. Whereas in the case of mechanical gauges, the fluid pressure is balanced by spring action. Dead weight or elastic strength of diaphragm. Mostly manometers are used to measure fluid pressure at a point and difference of fluid pressure between 2 points. And mechanical gauges are used to measure very high pressures. Also, dead weight gauges are used to serve as standards of comparison or for calibration of other pressure gauges. Thus, fluid pressure is an important concept, understanding of which is the basic foundation of the subject of hydraulics and for design of hydraulic structures. The invention of Pascal's law not only helped in the practical application of the knowledge of hydraulics, but also in the design of pressure measuring devices. When a layman talks about the design of dams, surge tanks, penstocks, hydraulic gates, and many other such devices, little does he know that it would have been impossible without the knowledge of fluid pressure and its measurement.